Hey everybody, this is Ms. McClellan, here to go over notes 8.4.2 with you, arcs and sectors. I will be able, 1, calculate the area of a sector and length of an arc when given a radius and central angle for a circle. Number 2, you should be able to interpret story problems and choose appropriate solutions, methods for arcs and sectors. The circumference of a circle is 2 pi r. This is the length around the circle. For most shapes, it's called perimeter. For a circle, it is called circumference. That's how much area a circle takes up. We've got central angle, we've got radius. So let's just quickly define them. So radius, diameter, oopsie, is twice the radius. So if I were to extend this distance here, the radius is half the distance across the circle, and the diameter is the whole distance across. Central angle is an angle whose vertex is at the center of a circle. Theta. Here is a central angle, theta. To celebrate their victory, the girls' cheerleading team, and we're changing this from ice hockey to cheerleading because our school does not have ice hockey, but we do have a cheerleading team which ranked 10th in the country at nationals this year. Wow. The goalie eats half of the pizza that has a diameter of 20 inches. What is the area of the pizza that she ate? We will leave our answers in exact form, that is, in terms of pi. Okay, so let's draw this circle. The diameter is 20 inches, meaning the radius is 10 inches. And she ate this half. What is the area? Well, the area for the whole circle is pi r squared. I want to make sure I put r in. R is 10. But I don't want the area of the whole circle. I want the area of just the part that she ate. And she had half of the pizza. So since she had half of the pizza, I'm going to divide this area in half. It's half of that. So let's see what this is. This is 100, that's 10 squared, times pi, inches, squared, all divided by 2. So she ate 50 pi inches. So I'm going to just say, even though it told us to keep it in terms of pi, and I'll box that answer, since pi is about 3.14, this is about 150 square inches. For example, an 8.5 by 11, a standard piece of paper, is 88 square inches. So it's about as much pizza as 2 regular pieces of paper. Okay, well, next problem. What is the length of the crust that she ate? For this one, we're going to need circumference. The circumference of the circle is 2 pi times the radius, which was 10. But I want the part that she ate, and again, she only ate half the pizza. I should divide the length of the crust by 2. So all the way around the circle of pi, we have 2 pi times 10, but she just ate half of it. So that's going to be 10 pi inches. And that's about 30 inches, which is just over 2 feet of crust. Now we're talking about Sonia. Sonia chooses a slice from another pizza, so we're not talking about the same pizza. This one has a diameter of 16 inches. 16 inches. That means that the radius, which is only halfway across, is 8 inches. If her slice has a central angle of 45 degrees, 45-degree angle, theta is 45 degrees. What is the area of her slice? Let's think about this. 45 degrees means that she's taking up, I think, an eighth of the circle. Is 45 divided by 360 an eighth? Yeah, it's an eighth. That makes sense, because if you have a whole circle, you break it into 90s, and you break it into, yeah, it's definitely an eighth. Okay, 1/8. So, if the area of the whole circle is pi times r squared, this is 8 squared, then I would take that total, and I only want an eighth of the circle, so I'm going to divide by 8. See, 8 squared divided by 8 is just 8, so that's 8 pi inches squared. So Sonia ate 8 pi inches squared, and it's about 24 square inches. Well, now we need to know the length of that arc. We have an arc with radius 8, central angle of 45 degrees. So I want this distance here. I know that the circumference around the circle is 2 pi times r. And I only want an eighth of that because I'm only doing an eighth of the circle. So I will divide by 8, which means that this is really just 2 pi inches long, which is about 6 inches. Cool, moving on. As the evening draws to a close, Sonia notices that there's only one slice of the goalie's pizza remaining. She estimates the central angle to be 72 degrees. We use this estimate. What is the area of the remaining slice? Since we're talking about the goalie's pizza, I remember that the goalie's pizza had a radius of 10. That's from the first problem. So we've got a radius of 10 and a central angle of 72 degrees. And the question is, what is the area of the remaining pizza slice? Well, I know that the area of the whole circle is pi times 10 squared, since 10 is the radius. But I don't want the whole circle, I just want part of it. So I need to figure out how much of the circle I want. Well, what's 72 over 360? I think that'll give me the right fraction of the circle. Beep, bop, beep, bop. Put it in a calculator. It's about 0.2. 0.2. So all I want is 0.2 of the circle. I'm going to do the area of 0.2 times the whole circle, which is the same as 0.2 times 10 squared is 100 pi, 20 pi inches squared. This is about equal to 60 inches squared, which is less than the size of a piece of paper. What is the length of the crust? Now we're asked length of the crust. That'll be this distance here. What is this distance? Okay, well, I think I'll use the same method, except instead of thinking about area, I'm thinking about circumference. So I'm going to do the same fraction of the total. So I'm doing 0.2 times 2 pi r, where r is 10, which is 0.2 times 20 pi, a fifth of 20, so that's 4 pi inches, or about 12 inches. You keep going. Now we're defining these things. An arc is just a piece of the edge of a circle, and we talk about it in terms of its central angle. Let's add that to our references up top. I'm going to draw another circle. I'll have my central angle again. This is an arc. Now the question is asking, if a circle has a radius of 6 centimeters, what is the length of an arc with a central angle of 30? So I'm going to draw a circle. Got a radius of 6 and a central angle of 30 degrees. And I want to know, how long is this arc? What is this arc length? Usually we call arc letter S. Here we have S, and it's going to be equal to circumference. 2 pi r. This is the total circumference. And then how much of the total circumference? Well, it is my central angle, theta, divided by 360. That's the fraction of my angle, my central angle over 360. So for this problem, we have S equals 30 degrees over 360 times 2 I times r, which is 6. Now I'm going to put pi on the outside because then I can do the rest of my calculator. So this is equal to 30 over 360 times 12 times pi, which, would you believe it, is just pi. .30 is a very special angle, and 6 in this situation is the perfect radius to show us that. We continue. Now we define sector. So this is the word sector. A region that resembles a slice of pizza is called a sector. Well, I'm going to add sector first to our references up top. So if this is an arc, the pink, then the sector, I'll do sector in green, would be this piece. Okay, let's do that problem now. So now we have a circle with a radius of 10 feet, a central angle of 20 degrees, and we want to know the area of that sector right there. What's the area of this sector? The area of the sector is going to be some portion of the circle, which is going to be, so here we have a circle with radius 10. The area of the circle is pi times the radius squared. So that's pi times 10 squared. And the angle we're talking about right now is 20 degrees. So that's going to be 20 over 360. So this is equal to, if I put the whole thing in my calculator, I get about 17.5 units squared. This area is square units. Okay, we keep going. So 889 says, it is useful to be able to calculate the area of a sector for any circle. So we're going to look at our work from problem 888 and describe the relationship between the area of the sector and the area of the full circle. So in 888, we have the area of the sector is the total area of the circle multiplied by the fraction of the circle the angle takes up. The central angle takes. So the area of a sector is equal to the area of the full circle multiplied by the fraction of the circle the central angle takes up. So the area of the sector is equal to the area of the full circle, that's pi r squared, multiplied by the fraction of the circle taken up by the central angle. So that's theta divided by 360 degrees. And there we have a formula for calculating the area of any sector. And we continue. Now we're going to use our formula and do a little investigation about how a central angle impacts the fraction of a circle that a sector takes up. What is the length of the marked arc for each circle? Here we're looking at circles D and E. So first we're asked to find the arc length. So that's S is equal to the circumference of the whole circle, 2 pi r, multiplied by the portion of the circle taken up by my central angle. So 30 over 360, and I'll replace r with the radius from each circle. So for D, r is 3. So make sure that it's clear that this is the arc for D. And for E, we have the same thing, except r is now going to be 5. So 30 over 360 times 2 pi times 5. Let's simplify these. So to simplify these, I'll put pi on the outside. So I'm going to multiply all the number parts together, and then I'll leave pi on the outside because I'm asked to keep this in terms of pi. So this is going to be 30 times 2 times 3 all over 360 times pi. And I can start canceling things. So this 3 becomes a 1, and this becomes a 120. And I can say this 2 becomes a 1, and this becomes 60. And then I have 30 over 60 pi, which is pi over 2. Okay. For this problem, I'll do the same method. So I'm going to write all the numbers together. 30 times 2 times 5 all over 360, and then multiplied by pi. On top, I'll divide by 2 first. 180. Then I'll divide by 3. That makes the bottom into 6. So this becomes 5 pi over 6. And now I have my lengths of my arcs. Okay, part B asks, for circle D, what is the ratio of the arc length to the radius? So that's going to be pi over 2 divided by the radius, which is 3. So that's the same as saying pi over 2 times 1/3, which is pi over 6. And now we're going to do the same thing for circle E. What's the ratio of the arc length to the radius? Well, that's going to be, for this one, 5 pi over 6 divided by the radius, which is 5. And this is the same as 5 pi over 6 times 1/5, which is the same as just pi over 6, because the 5's cancel. So, hey, would you look at that? It's the same both times. And it really should be, because a ratio is, in this situation, just a fraction. And I should be taking up the same fraction of my circle if I have the same central angle on both. Okay, now we have another. Suppose circle F has a radius of 100 units and an arc with a central angle of 30 degrees. Seems a little familiar. So here we go. Radius of 100, central angle of 30. What is the ratio of the arc length to the radius? Well, look, I'm just gonna say it's probably pi over 6. Because it should be the same as the other ones. It's the same amount of this circle. Certainly this arc length would be longer than the others, but compared to itself, it would be the same. It would be the same fraction of its full circle. Part E. There are other units of measure besides degrees that can be used to measure an angle. For example, the radian measure of a central angle is the ratio of the arc length to the radius of the circle. Why will all arcs with a central angle of 30 have the same radian measure? Well, it has to do with how our radian measure is being defined. So let's take a close look at that. Radian measure is the ratio of the arc length to the radius of the circle. Consider the previous problems we just did. Consider our previous problems. Particularly that we've done within 8-90 or 8-90. In each one, we compared a ratio of arc length to the radius of a circle. And we said that if the angle does not change, we've been working with 30 degrees, so we'll say stays 30 degrees, but you could really do this for any angle, then the ratio doesn't change. So if a radian measure is defined as being this ratio, then it follows that all arcs with central angles of 30 degrees have a radian measure of pi over 6, period. And that's the end of our notes today. Let's take a quick review of the important takeaways. Okay. This is important, part E, that we just did, but it will be further emphasized in later lessons. The things that we did in this lesson that you need to take with you when you go are the formulas for area of a sector. This is the area of a sector. And the length of an arc. This one is the length of an arc. And you should be able to use those formulas. Okay, that's it. I'll see you next time. Have a great day. Bye.